To another live stream from Scalar Learning, and today we are continuing with SAT stuff from SAT Math from Khan Academy. It's a great resource for SAT Math questions. And really the main criteria we're talking about is accurate to what you'll actually see from the College Board, and they're great. Okay, so here we go. Well, the harder level problems, there's a little discrepancy, but I think they're still great practice. So today we are tackling solving linear and quadratic systems right here. Boom. And let's begin. Now, if you're new to these live streams, again, I'm solving these problems for the first time on the spot, which is part of the fun. So you can see the problem solving process up close. And let's do it. So it looks like this function is, or not function, but relation, I guess, is mapped here. Which of the following are the two solutions to the system of equations formed by this equation in the line y equals 1/2 x plus 3, which is not graphed? Well, definitely 3. This one, because, okay, I can solve this by setting these two equal to each other, right? But I already know this is a linear equation that has a y-intercept of 3 and a slope of 1/2. I can probably figure out, look, I can probably figure this out just graphically. So let's do that here. I'm going to just move this over here. And the good thing is on the SAT, you can actually, do this. You can write straight on the graph, or on the test, I mean. So here we go. So check this out. Oh, it's blurry. Here we go. Boom. So here's 3, and then it's got a slope of 1/2. So we can apply it either up and over 2, and then going backward down over 2, down over 2, down over 2, down over 2, right? I think this is faster than trying to solve it algebraically. And there is the other intersection point. So we can kind of draw a line through here. And there's my two intercepts, or there's my two solutions, you could say. Here is 0, 3, and here is -12, -3. -12, -3. There we go. Boom. Okay, next. Graph to the left shows that parabola, which of the following is the solution system equations between that and that. I wonder if I could do the same thing here. I feel like that might make the most sense. I mean, we can also plug, this one's a little faster, I think, to plug in. All right, let's do this one algebraically just for fun. I'll show you. So look, we've got these two equal to y. If we want to know the solution, let's just set them equal to each other. So it's hold on, let me zoom in a little. It's 120x plus 50, that's this guy, equals to this guy, -36x squared minus 50. Let's set everything equal to 0 by bringing these guys over here. So I'm going to add 36x squared and add 50. So 36x squared, keep that guy, right? You see how I added it and became positive? And then adding, because that's a -50, so adding it to that 50, it becomes 100. And then now let's factor. Oh, wait. Let's make this easier. We can divide everything by 2, I guess. Now, you know what? By 4. So this becomes 9x squared plus 30x plus 25. I feel like this is a perfect square. But let's see. So I think it's going to be like 3x. Yeah, it is. 3x plus 5 times 3x plus 5. Right, because that gets us 9x squared, 15, that's 30x. 5 times 5 is 25. There we go. So my solution is simply where 3x plus 5 equals 0, right? Because it's whatever value makes this go to 0 for x. Now let's subtract by 5, 3x equals -5, x equals -5/3. So -5/3 something. It's this guy. Boom. Next. We've got two functions. It's the same thing. But this is a little longer. Oh, all right. So this we're going to have to do a little substitution. And hold on, is there a faster way to do this? I don't think so. All right, so up here I'm going to isolate y, and we're going to do a similar type of thing. So we have 2x minus 15. I'm going to swap that and swap that equals 3y. Divide everything by 3. Get y equals 2x over 3 minus 5. I'm going to plug this into the y here. So then I have 2x thirds minus 5 equals, and I'll go ahead and, I'll leave it like this. 1/3 x squared minus 16x plus 63. Now I'm not going to distribute this 1/3. I was going to, but I'm not, because instead I'm just going to multiply both sides by 3 and get rid of that fraction. It's going to be so much easier once I do that. So this times this becomes 2x. 3 times -5 becomes -15. And then the 3 just knocks this entire 1/3 out equals, actually, you know what? Let's make it -3. This will be nicer. So this becomes negative. This becomes positive. And then this just goes away completely as 1. So we now have a nice x squared minus 16x plus 63, just so I didn't have to deal with distributing that negative. Now let's bring everything to one side, so I'll move it this way since I like having that x squared positive. So we're going to subtract 15 and add 2x. So adding 2x to that becomes 14x, right? 2x plus -16x is 14x, -14x. And then subtracting 15 from both sides. That is 58, 48. And now let's factor this guy. Let's see, what multiply? All right, it's -6 and -8. Because they multiply to positive 48 and add to -14. And so wait, there's two solutions. Hold on. 8, 6, or 8. What is the value of x? But why? See, this is a, unless I'm misinterpreting something, this is a poorly written question because there's two solutions. It should say what is one of the values of x, or what is a potential value of x, not what is the value of x. Oh, and y is greater than 0. Got it. That's the thing. Okay, so let's plug these values in. So if I plug 6 in for the original equation, it's like 2 times 6 minus 3, y equals 15. 12 minus 3y equals 15 equals 3. So in this case, y equals -1. That's for 6. So 6 it must be 8. But anyways, let's try it. So now I'm going to plug in 8 for x and solve for y. 2 times 8, y equals 15. This is 16 minus 3y equals 15. -3y, yep, equals -1. Y equals positive 1/3. So it's 8. Boom. Yeah. See, and they also gave that 6, but then it gave negative. Okay. 2 questions left. Same dealio. A, B is a solution, and B is greater. Okay, so it's the exact same as the last one. Let's go ahead and substitute. So I'm going to plug in, and this is isolated already, so it's, oh no. Then I have to FOIL it. What's an easier way to do this? Let's do it the other way. Let's plug in for x and solve for y. It's much better. So I'm going to isolate x here, so it's y plus 9 equals 1/5 x. Multiply both sides by 5, and I get 5y plus 45 equals x. Now I plug that in over here. So now it's 5y squared plus 15 equals 7 times 5y plus 45. See how I just plug that in? I can kind of distribute this guy. 5y squared plus 15 equals 35y plus 280 plus 35 is 315, right? Yeah. And then divide everything by 5 because I see everything's divisible by 5 here. So we have y squared plus 3 equals 7y plus 63. right? Yeah. Okay, now let's isolate everything. So y squared minus 7y. Subtract 63 minus 3, basically. Or negative 63 plus 3 is negative 60 equals 0. Okay, let's factor. We need what multiplies to negative 60 and adds to 7. Negative 7. 20 and 3, 15 and 4, 12 and 5. Negative 12 and positive 5. Which means that the two values are negative 5 and positive 12. And boom, 12 is the positive one. That's all we're looking for. Yeah. All right. Last but not least, here we go. Two distinct solutions to the system of equations. What is the product of the x values of the two solutions? Why did they make this one so complicated? Let's see. Well, I'm just trying to wrap my mind around it because I want to isolate. I just want to solve for x. Okay. Oh, this is going to be a pain. x1, x2. Because that's going to be a problem. Plug in x and I solve for y. Hold on. If I isolate y and plug in for x, it's going to be a whole thing. Let's just go for it, whatever. Okay, so the reason why I was hesitating is because I want to isolate y and solve for x. Because we're solving for x, it'll save us some time. But it's going to be a big pain, but it is what it is. I think let's just try it. Negative 11x. No. You know what? Forget that. Let's solve for y and then we'll plug it in, get the x's. Okay, so I'm going to isolate x here. So negative 11x equals 62 minus 3y divided by negative 11. Okay, so x equals this. Therefore, we have negative 2 minus 62 minus 3y over negative 11 equals y squared minus 4y plus 10 over 11. Multiply both sides by 11. See how nice this is? Actually, let's get this in here because this can go in here and cancel out with this guy, right? Because that minus just hits that, so now it's a nice plus. Now we multiply everything by 11. We get negative 22 plus 62 minus 3y, right? Because that goes away. Equals y squared minus 4y plus 10. This goes away because we're multiplying everything by 11. So all these guys cancel out. Now let's isolate. So I got y squared. I got a minus 4y. Let's bring plus 3y over here, and that's minus y. These guys combine to become 40. And then subtract 40 over here, and we get negative 30 equals 0. Okay? That's moved over, so we're good now. And now let's factor this. Multiplies to negative 30, adds to negative 1. That's minus 6 and plus 5. Okay? So my solutions for y are 6 and negative 5. Now we plug them in here and solve for x. So negative 11x plus 3 times 6 equals 62. So that's 18, 62. Subtract 18, subtract 18. Negative 11x equals 42, 44. X equals negative 4. So this is one value because we want x1 times x2. And then let's plug in negative 5. Negative 11x plus 3 times negative 5 equals 62. And that's negative 15 equals 62, negative 11x. Add 15, add 15. Negative 11x equals 77. X equals negative 7. Alrighty, so we've got negative 7. Negative 4 times negative 7 is positive 28. And we are done. Boom. All right. Yeah. All right, that's it for today's live stream. Hope that you found that was helpful. If you did, please click that like button. It really helps me out a lot. So please, please, please do that. And if you want to see more from the Scalar Learning channel, which I hope you do, if you want to study math or learn about study tips and everything like that, click that subscribe button right below. I'm going to quickly answer a couple questions. So, how am I so good at math? I'm going to answer that is practice, practice, practice. That's no joke. Right now, I do this all the time, every week. I'm constantly tutoring. Got a bunch of tutoring appointments today that I got to leave for soon. Will the last question likely going to be in the test? I think these are on the very, very complex side of what you'll see on the. I don't think it'll ever be this hard. I've said that a few times. The level, the type of caliber of problems that I've been answering lately from Khan Academy, I think they actually go beyond the test, to be quite frank. And I'm actually, once I get through this round of Khan Academy, I'm going to be switching to some other resources. But yeah, after all the College Board tests that I've seen and the 2 official ones that I've taken in the last 2 years, no, I don't think it'll be this hard. Something like this, definitely solving systems of equations, definitely potentially with quadratics and linear combined. But I think these are definitely harder than what you'll see. All right, thank you guys so much. I got to roll out and start my day of tutoring. It was great to see you, and I'll see you guys. Remember, live stream tomorrow, more SAT, Khan Academy math, same time, 7 a.m. PST. Sorry I was a little late today, guys. I really apologize. Just running a little behind schedule. But tomorrow, 7 a.m., I'll see you guys then. Take it easy.